So for this question, we are given a quadratic function in vertex form. This is the function here, f of x equals 1/3 x minus 3 squared plus 3. And we want to address the following. We want to sketch the graph and find the domain and range. So this quadratic function is in vertex form, or sometimes called standard form. And what that means is that our function follows this particular pattern, a times x minus h squared plus k, where hk, the ordered pair hk, is the vertex of the graph of the parabola. So looking at our example, you can see the h and k being 3 and 3. So we have the vertex of the parabola. This provides information on how we're going to draw that parabola, where that vertex is. So with a parabola, you either have an up-facing parabola or a down-facing parabola when your quadratic is a function. And the vertex is at these turning points here. So we're going to use the value of a, which in our example is 1/3, to determine which one. Whenever a is greater than 0, we have an up-facing parabola. And when a is less than 0, we have a down-facing parabola. So our a is 1/3, and because that is greater than 0 or positive, we know that our parabola opens up. So we have a pretty good idea of how to sketch the graph at this point. I'm going to draw where the vertex is, 3, 3, which will be here, and we know it's facing up. However, we don't know how wide or thin the parabola is going to be, and that is also determined by the value of a. When a is equal to 1, that is our base function, and if we think about what that graph looks like, we have 0, 0, 1 squared is 1, negative 1 squared is 1, and so you can see that that point is 1 over and 1 up, 1 over and 1 up away from the vertex. But when a is equal to 1/3, that point will be, instead of 1 away, 1 up, it'll be 1/3 up. Now, we have some restrictions here because you guys are doing this problem in my math lab, and my math lab restricts you to clicking only on the points where you have a grid point. So because the y is 1/3 for that point, because the transformation moves that point to 1/3, you're not going to be able to click that point to draw the graph. So you have to find a point that is matching the grid that you have. So it has to be a whole number in order to draw the graph using MyMathLab's tools. So what you need is a second point on the graph that happens to be using integers. So I would suggest looking for maybe an x-intercept or a y-intercept. In this example, a y-intercept works. So if you find the y-intercept, you're going to let x equal 0, and for your function that's f of 0. And you have 1/3 times 0 minus 3 squared plus 3. So we'll follow order of operations inside of the parentheses. 0 minus 3 is negative 3. Negative 3 squared is 9. 1/3 of 9 is 3. And you have 3 plus 3 is 6. So this gives you a second ordered pair on the graph, 0, 6. And because those are both integers, my MATLAB will accept that second click. And you can see how wide the parabola is from there. This question also asks to find the domain and range. The domain is the x values, and the domain of every quadratic function is all real numbers, negative infinity to infinity. And the range, we're going to use this vertex. That is the first y value in the range, and all the y values going up from there are included in the range. So our range starts at 3 and goes to infinity. 3 is included because the vertex is included in the graph of the parabola. On this question, we want to use the quadratic function f of x equals x squared plus 2x minus 12 to address the following questions. We want to find the vertex. We want to determine if the parabola opens up or down. And we want to find the axis of symmetry. So let's start with the vertex. There are two different ways for us to find the vertex when the equation is written in this general form. The two different ways involve a vertex formula or a process called completing the square. So I'm going to show you both. With the vertex formula, the vertex is usually written as an ordered pair HK, and the formula that we have for the vertex is negative b over 2a. The letters a and b refer to coefficients of the different terms in our quadratic. So when we have our quadratic, we say that it's written in ax squared plus bx plus c form. That's the general form. And a represents the coefficient on the squared term, b is the coefficient on the x term, and c is the constant. So looking at our example, our x squared term has no number as the coefficient, so we assume it to be 1. So a is 1. The coefficient of the b term is a 2. And the constant is negative 12. So we're going to work this out with the formula. Negative b is negative 2 over 2 times a, which is 1. Negative 2 over 2 is negative 1. And then we're going to find the y part of our vertex, k, by substituting into our function. So we're going to take that negative 2 and substitute it into the function to get the y part. So that's f of negative 1 is negative 1 squared plus 2 times negative 1 minus 12. Negative 1 squared is 1 minus 2 minus 12. 1 minus 2 is negative 1, and 1 minus 12 is negative 13. So we have the vertex of our quadratic function, our parabola, being negative 1, negative 13. So that's one way to find the vertex, using the vertex formula. Let's try the other way, which is using completing the square. When we complete the square, we start with our function, f of x equals x squared plus 2x minus 12. And this function, this quadratic function, is in general form. What we're going to do is try to rewrite it in the vertex form, which is a times x minus h squared plus k. And when we write it in that vertex form, it's very easy to recognize what the h and the k are. and that is our vertex. So with this completing the square process, you first want to group these x terms together and factor out the coefficient on the x squared term. On this example, because x squared doesn't have a coefficient, we don't have to factor anything out. So we're just grouping it together. Then I'm going to make a little bit of room inside this grouping for what I call the magic number, and this magic number is going to complete the square. So let me do the work on the side. You're going to start with the coefficient on the x term, 2. You divide that by 2 and then square it. 2 divided by 2 is 1, and 1 squared is 1. So our magic number for this example is 1. And we want to write that magic number inside the parentheses. But you're not allowed to just write any number you want. You have to keep an equation that is balanced. So whatever I change in the equation, I have to balance it out by doing the opposite. So I wrote a 1 inside the parentheses. There's a 1 outside the parentheses. So if I multiply those two together, 1 times 1 is 1. So by writing a 1, I've added a 1 to this equation. To balance that out, I need to subtract 1. So now I'm ready to factor what's in the parentheses. In the parentheses, this factors to be x and x. 1 times 1 is 1. Positive 1 plus positive 1 will give me a positive 2 in the middle. And then negative 12 minus 1 is negative 13. The x plus 1 times x plus 1 becomes x plus 1 squared. And we've now written this equation in the vertex form. You can recognize the h and the k from the equation, and we get a vertex of negative 1, negative 13, which is the same vertex we got with the other method. So either one is acceptable to find the vertex. So let's move on to the other parts of this problem, part B. Does the parabola open up or down? And to determine that, we want to focus in on the coefficient of our squared term, a. And whenever a is positive or greater than 0, we know that the parabola will open up. And when a is less than 0, it will open down. So in our example, we have a coefficient of 1 on our x squared term, and a coefficient of 1 even when it's written in the vertex form. That's positive, so that means that this parabola opens up. And then finally, the last question is axis of symmetry. Every parabola is going to be symmetric around its vertex. So if we just sketch a graph of a parabola, its vertex is here. And if we draw a vertical line going through that vertex, you can see that we have a mirror image on either side of that vertical line. So we call that line the axis of symmetry. So it's a vertical line. The equation of a vertical line is always x equals a number. And because our vertical line is passing through the vertex, we can use the x coordinate of our vertex to create that axis of symmetry. So x equals negative 1 is the axis of symmetry. Okay, so here's another question that I've been asked. This question says, to use the quadratic function f of x equals 5x squared plus 10x minus 6 to address the following. We want to find any x-intercepts and find any y-intercepts of this function. I'm going to start with the y-intercepts, even though that's part B. So to find a y-intercept, you let x equal 0. So we're going to substitute a 0 into our quadratic function. That would give 5 times 0 squared plus 10 times 0 minus 6. And 0 squared is 0, times 5 is 0, 10 times 0 is 0. Carry down that minus 6, and 0 plus 0 minus 6 is a negative 6. So we have a y-intercept of 0, negative 6. Then we're going to look for our x-intercepts. To find an x-intercept, we let y equal 0. We're using function notation, so f of x is the same thing as y. We're going to set f of x equals 0. And that's going to lead to the equation 0 equals 5x squared plus 10x minus 6. So this is a quadratic equation. And there's probably more than 4 methods, but 4 that I typically teach for solving quadratic equations. There's factoring, there's the square root method, completing the square, and the quadratic formula. Factoring and the square root method are methods that don't always work. Not every quadratic can be factored, and not every function, not every equation is written in a form where the square root method can work. But they're typically easier methods to use. The other 2 methods, completing the square and the quadratic formula, those methods do work on every single quadratic, but they can be a little bit tedious. So I typically take the approach when solving a quadratic equation to try to factor first, or if it's possible to use the square root method first. And if those methods don't work, then I go to the quadratic formula. So if I were to start this with factoring, and by the way, I've already ruled out the square root method, because with the square root method, you have to have your b term, your middle term, gone. So you can only use that square root method if you only have the square, not the square and the linear term. So factoring is the one I'm going to try. And if I were to factor my front of the factorization, the first terms in the binomial would need to be a 5x and an x, so that it would multiply to be 5x squared. For the second terms in each binomial, they would need to multiply to be 6, and we have a couple choices there. It could be 2 times 3 or 6 times 1, so I'll try both of them. So 2 times 3 would give me 6, and then I need to check to make sure that I would get the right middle number of 10. So I would check multiplying the inside and the outside. That's a 2x and a 15x. And if I combine those by either adding or subtracting, that's not going to give me the 10x in the middle. So I know this is not going to work. So then I try something else. I try the 3 over here and the 2 here. So that would give 3x and 10x. 3 and 10 are not going to add and subtract to give me 10x, so that's not right. So let me try the 6 and the 1. I'll try 6 and 1. That's 6x and 5x. That doesn't give me 10. Let's try the 1 and 6. 1 and 6 gives me x and 30x. And that doesn't give me the 10x in the middle. So factoring does not work here. We've tried every combination, and factoring doesn't work. So now I'm going to go to trying the quadratic formula. So with the quadratic formula, I would let a equal 5, b equal 10, and c equal -6. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I've got -10 plus or minus the square root of 10 squared minus 4 times 5 times -6 all over 2 times 5. So I'm going to use order of operations to simplify. So inside of the radical, I'm going to apply the exponent first. 10 squared is 100. And 4 times 5 is 20, and 20 times 6 is 120. That's going to be a plus. And 2 times 5 is 10. Let's continue this up here. We have -10 plus or minus the square root of 220 over 10. And now I want to simplify the radical. When you simplify the radical, you would like to have a factorization of 220 that contains a perfect square. And you want that because the square root of a perfect square will simplify. So looking at 220, let's do this work on the side. So looking at 220, there are lots of different factorizations of 220. 1 times 220, 2 times 110, 4 times, let's see what, 55, 5 times 44. 6 is not going to work, 7's not going to work, 8's not going to work. How about 11? 11 times 20. And I'm trying to think if there are any more. 20 is 2 times 10. Yeah, we skipped 10. So I skipped 10. 10 times 22. But all of these, if you look at all of these, there's only one of them with a perfect square. 4 is a perfect square, which is 2 squared. So that's the one we want to use so that we can actually simplify the square root. We've got -10 plus or minus the square root of 4 times 55 over 10. The square root of 4 is 2, and 55, since it's not a perfect square, will stay underneath the radical. We can't perform that operation without a calculator. I'm sure somebody can perform it without a calculator, but not me. The final thing that we want to do here is that we have a fraction, and you always want to write fractions in lowest terms, no common factors between the numerator and denominator. And so looking in the numerator, I have 10 and 2, and both of those are even, divisible by 2, so we have a factor of 2 in the numerator. And in our denominator, we have a 10, also has a factor of 2. So I can factor a 2 out of the numerator. Oops, sorry. So if I factor a 2 out, this becomes -5 plus or minus square root of 55 over 10. And now the 2 and the 10 can cancel. 2 goes into 2 one time, 2 goes into 10 5 times, and that's going to give us -5 plus or minus square root of 55 over 5. So this is an acceptable answer for us. However, some people do like to write this as, instead of one large fraction, two separate terms. So if you write it as separate terms, you would divide the 5 that's in the denominator into both terms that you see in the numerator. So you would write negative 5 over 5 plus and minus square root of 55 over 5. That would give you negative 1 plus or minus square root of 55 over 5. So this is also an acceptable answer. If you guys are doing this in my math lab, it will mark you correct on either one of these. For this question, we have a picture of a quadratic function on the right, and we have some questions about this quadratic function. We want to know, is the leading coefficient positive or negative? What is the value of h? What is the value of k? What is the value of the leading coefficient a? Then we want to write the equation of the function in vertex form, which is given here, and write the equation of the function in general form, which is given here. And what we want to take notice of is that a couple points have been marked for us. This point here is the ordered pair 4, 5, and it's marked right here. This is a special point on the graph. This is the vertex. And we label the vertex with the ordered pair HK in our formulas. And then we're given another point on our graph, and this point is the ordered pair 5, 9. And it does not have any special notation. It is just some ordered pair that is on the graph of this particular function. So let's go through the questions with this information. So the first question says, is the leading coefficient positive or negative? Now, we're looking at this graph, we can see that this parabola is oriented up. So because that parabola is oriented up, we know that our leading coefficient A is going to be greater than 0 or positive. So by the orientation of our parabola, we know that A, our leading coefficient, is positive. In the next question, it says, what is the value of h and what is the value of k? So we're talking about our vertex, and our vertex was labeled on the graph with 4, 5, and so h is 4 and k is 5. So we know the value of our h and k, which is the vertex of our parabola. In part C, we want to find the value of the leading coefficient. So this is going to require some more work, in fact, solving an equation. So our strategy for this is to start off with the vertex form. F of x is equal to a times x minus h squared plus k. And we have the value of h, and we have the value of k. We're hoping to figure out the value of a. Now we also have this ordered pair, 5, 9, and we're going to use that as an x and a y. This is the x, and f of x is the same thing as y. So we have values to substitute for all the variables except for the one that we're trying to solve for. So we're going to be able to substitute those numbers in and solve for the value of a. So substituting those values in, we'll get 9 equals a times 5 minus 4 squared plus 5. So remember that this is the h and k here and here. And then we have our x and y, and that's how we substituted into our equation. So we're going to simplify, and we have 9 equals a times 5 minus 4, that's a 1, and 1 squared is 1, so we have a times 1 plus 5 on the right, and a times 1 is a, so we have a plus 5 on the right, and we can solve for a by subtracting 5. That gives a equals 4. So now we know that value of a, our leading coefficient, is 4. In the next part, we want to write the equation in vertex form. To write the equation in vertex form, we just need to substitute the value of a that we just found, the h, and the k that we had earlier. So in vertex form, we're going to have f of x equals 4 times x minus 4 squared plus 5. So that is the equation of our function in vertex form. In our final part, we want to write the function in general form, which is our expanded form, f of x equals ax squared plus bx plus c. So to write it in this expanded form, we're going to take our vertex form and do a bunch of algebraic simplification. So we're going to apply that exponent. That's x minus 4 times x minus 4. We're going to multiply out those binomials to get x squared minus 4x plus 16. Carry down that plus 5. I'm going to simplify inside the parentheses by combining like terms. Negative 4x minus 4x is a negative 8x. And I'll distribute the 4. That gives 4x squared minus 32x. And let's see, 16 times 4 is going to be 64. And I'll combine like terms. 64 plus 5 is 69. So now we have our general form of the quadratic function being f of x equals 4x squared minus 32x plus 69. So given the quadratic function, f of x equals 2x squared minus 11x minus 9, and we want to address the following. Does the function have a maximum or minimum value? And what is that maximum or minimum value? So because we are dealing with a quadratic function, we can tell whether we have a maximum or minimum value by the orientation of our parabola. So looking at this quadratic function, the value of a is always attached to the squared term. So our a is equal to 2, and that is a positive value greater than 0. And because of that, the orientation of the parabola is going to be up. The parabola is an up-facing parabola. And so this quadratic function will have a minimum value at the vertex. So it's got the y value being the lowest at the vertex. So we can say that this function has a minimum value because the orientation is up. And then we can find that minimum or maximum value by finding the vertex. I'm going to find the vertex with the vertex formula. And the vertex formula is negative b over 2a. You'll have to excuse me, I should write this as and h. We usually label our vertex as hk. So our formula for the vertex is negative b over 2a. The value of b is negative 11, and the value of c is negative 9. So when we're finding this vertex, we're going to substitute into the formula. That gives negative 11. So I'm using the negative from the formula, and the number is negative, so I want to make sure that I include both of those negatives. Sometimes we forget that. We have 2 times a, which is 2. So we have our h being positive 11 over 4. So then we're going to find the y part of our vertex. And to find that y part of the vertex, I'm going to substitute the x into the function. So I'm doing f of h, and we just found h. So that's f of 11 over 4. So in this example, we would have 2 times 11 over 4 squared minus 11 times 11 over 4 minus 9. So we're going to have to be really careful with our arithmetic here since we have fractions. So 11 over 4 squared would be 121 over 16. And 11 times 11, that's 121 over 4 minus 9. And then I can reduce this fraction a little bit because the 2 will cancel with that 16. So I have 121 over 8 minus 121 over 4 minus 9. And to combine these together, I would need a common denominator. So I'm going to multiply the 121 over 4 by 2 over 2 to create a common denominator of 8. And I'll multiply the 9 by 8 over 8 to create that common denominator of 8. That's going to give 121 over 8 minus 242 over 8 minus 72 over 8. The 121 over 8 minus 242 over 8 will be negative 121 over 8 minus 72 over 8. And negative 121 minus 72 would give me a negative 193 over 8. And the minimum or maximum value will be the y part of our vertex. So the negative 193 over 8 is our minimum value. Now you could also use your calculator and get a decimal approximation for this. So let me bring my calculator up. And I've got this calculator here that I've downloaded. And it's got a negative 193 over 8. And that gives me a negative 24.125. And both of these answers are valid, but you just want to pay attention to the directions to see if any details were given on how the answer should be written. I noticed I didn't have it pasted on the screen here, but I noticed that in the directions it said to write a integer or simplified fraction. So this is the answer that would be accepted by the computer system. Thank you for checking out my videos. Have a great day.